Hello everyone. In this question, it is asked that we are to find the solution set of the inequality, and the inequality is logarithm of 3 minus 2x to the base cos x square is less than logarithm of twice x minus 1 to the base cos x square. Okay, so this question, this looks very complicated. So let us first start with the, let's say, the definition of logarithm. Okay, when is the definition of logarithm valid? Okay, so we know logarithm of x to the base a is defined if the base a is greater than 0, it is not equal to 1, as well as the component whose logarithm is being taken. Okay, in this case x, this x has to be positive real number. Okay, this is the definition for a real logarithm. Okay, so these are the criterion. So for our inequality to make sense, first of all we have to at least make the logarithms be defined first. Okay, so in that manner, if we start, we have to get 3 minus 2i's x. This has to be positive, right? X is greater than 0, so this has to be positive first. So if this is positive, this implies that let us multiply both sides with minus 1, then we get twice x minus 3 is less than 0, right? So this implies x is less than 3 upon 2. Okay, this implies x is less than 3 upon 2, and we must have from the other side twice x minus 1. This has to be defined, so this implies twice x minus 1 is positive. This implies that uh, twice x twice x is greater than 1, and this implies that x has to be greater than half. Okay, so x greater than half and x is less than 3 upon 2. So if we combine both of these, combining combining means we take the intersection. We see that x belongs to this interval, half to 3 upon 2. Okay, 3 upon 2, this 3 upon 2 is 1.5 and half is 0.5. Okay, so combining we get x is so far we get x belongs to this range, half to 1.5. Okay, now let us look at the base. The base is cos of x square. Okay, so base also has to be positive, and the base cannot be equal to 1. So let us now apply those criterion now. Okay, so cos of x square has to be greater than 0. Okay, and cos x square cannot be equal to 1. So in this interval, for cos theta, let us consider for a second cos theta. Okay, now cos theta is greater than 0 when theta lies in the first quadrant, right? First quadrant, that is 0 to pi upon 2. Okay, cos theta is positive in that domain. Okay, so in our case, if x is in this range, if x belongs to this half to 3 upon 2, this implies x square will lie between, if we square this we get 1 upon 4, and if we square this we get 9 upon 4. Okay, so this is the range where x square will belong to for x, right? If x is belonging to half comma 3 by 2, x square belongs to 1/4 upon, or 1/4 to 9 upon 4. Okay, so this is the range of x square. Now we must have cos x square to be positive, but it cannot be equal to 1. Okay, so in that case we have to look for the values where cos x square is positive. Now x square can take these values, right? Okay, so pi upon 2 is 3.14, 3.14 upon 2. So this is 1.57. Okay, after pi by 2, it goes into the second quadrant where cos is negative, right? Only sine is positive in the second quadrant. So if cos of this theta has to be positive, theta must lie from 0 to 1.57. But in our case, this x square goes from 0.25 and 9 upon 4 is 2.25. Okay, so this crosses 1.57, right? 2.25 is to the right of 1.57 on the number line, right? So x square goes into the negative territory. So if cos of x square is to be positive, then x square must be restricted from x square must be let me draw a number line first. Okay, so in the number line, if 0 is here, this is 1.57, say, that is pi by 2, and then here is 2, and here is say 2.25, right? Okay, so and here is suppose say 0.25. So x square goes from 0.25 to 2.25. Okay, but cos of x square, if it is to be positive, it has to be kept between this 0.25 to this 1.57 pi upon 2, right? So x square, if cos x square is positive, then x square must be kept between 0.25 to 1.57. 1.57 is approximately it is approximately pi upon 2. Okay, otherwise it will go into the second quadrant where this is negative. The value of this cos x square will get negative, and we don't know the logarithm with a negative base, so this inequation will not be defined, it won't be valid. Okay, so we are restricting the value of x square in the first quadrant. Okay, so it is between 0.25 to 1.57. So this implies that x will now be going from x will be square root of 0.25 will be 0.5, and the square root of 1.57, that is square root of pi upon 2, this comes out to be approximately, it comes out to be 1.25 something. Okay, so this is the range of x now, 0.5 to 1.25. Okay, for this expression to be valid. So first of all, we got x to be 0.5 to 1.5. Now we are getting x to be 0.5 to 1.25. Okay, so taking the intersection of this and this, taking intersection of 1 and 2, we see that x must belong to the common region, right? The common region, if we have 0 here, we have say 0.5 here, 1 here, 1.25 here, and then 1.5 right to the right of that. Okay, 1.5 is here. If we were to take the intersection of 0.5 to 1.25 and 0.5 to 1.5, the smaller region will be the common part, right? So intersection will give us x belongs to 0.5 to 1.25. Okay, so this is the, so far this seems to be the range of x. Okay, so if x is in this range, then cosine of x square, okay, cosine of x square will clearly lie, the value of this will clearly lie, will lie between 0 and 1, right? Because cos is in the first quadrant, right? And x neither takes x does not take the value of 0, or it doesn't take the value of pi upon 2, right? So cos x square, the value of this lies between 0 and 1, right? Maximum value of cos is 1, which happens for x equal to 0. X is from 0.5, starts from 0.5, so it cannot be, this cannot take the value 1. Okay, and x also cannot take the value of 1.57, that is pi upon 2, open bracket here. Okay, so this cannot become 0 either. So this implies that the base of log, uh, that is cos x square, lies in this region. Okay, lies between 0 and 1. So another point, this is a note, this is separate. Okay, if x and y are say natural numbers and x is greater than y, okay, and say a is another number that lies between 0 and 1, okay, then logarithm of x to the base a is always less than logarithm of y base a. Okay, this changes. Logarithm is an increasing function after 1, right? Log function is increasing from 1 to infinity, and it is decreasing in this range 0 to 1, right? And before 0, like log is not defined, real logarithm. Okay, so log function increases from 1 to infinity, and it is a decreasing function from 0 to 1. So after computing, we found that the base of this given inequality, this base of this logarithm lies between, the value lies between 0 and 1, right? This lies between 0 and 1. So this is this I don't know the proof. I can give you an example. Say, let me give you an example. If x say is 8 and y is say 4, okay, and say a, the base a is half, so half lies between 0 and 1. Okay, so if I compute the value of log x base a, here clearly x is greater than y. Okay, so base half, and we have 8 here, so 8 is 2 cube, right? And this is half. So can I write this as 2 raised to the power minus 1 times minus 3, okay, because minus 1 times minus 3 will give you plus 3 again. Okay, so this will further give me that 2 to the power minus 1 will become half, right? So this gives half raised to the power minus 3, and the base is half. So if I apply the property of log x to the power n, this n will come to the front of the logarithm, and we will get minus 3, and this is like log half base half is 1. Okay, so this is value of log x base a. Now if I compute the value of log y base a, we get log of 4 to the base half. Okay, so I can write it as log half to the power minus 2 to the base half, right? I have just done it like two steps in one. Okay, like I can write 4 raised 2 square, then I can separate it as 2 raised to the power minus 1 raised to the power minus 2. So 2 raised to the power minus 1 becomes half, and this power is minus 2. Okay, so now again applying the property of logarithm of log x to the power n, this n will come to the front of the logarithm, and this will become minus 2. So clearly minus 3 is less than minus 2. This implies that log of x base a becomes less than log of y base a if x greater than y and a lies between 0 and 1. Okay, so this shows that this is a decreasing function. I don't know the actual rigorous proof. I've shown it with an example. Okay, but this property is true. This holds good. If you see the logarithmic graph also, you'll see that this is a decreasing up to 1 and then increasing after 1. Okay, so this is just an extra note. Okay, this is like extra. This is not part of the sum so far. Okay, So in the sum, we found that the base of the logarithm cos of x square was between 0 and 1. Okay, so we are given in the inequality log of cos x square 3 minus 2x is less than log of base cos x square twice x minus 1. Okay, and base cos x square uh, is in the interval 0 to 1, that is it lies between 0 and 1. And so far we found that x belongs to this interval 0.5 to 1.25. Okay, 0.5 to 1.25. Okay, now again, since the base is between 0 and 1, and we are given log y is less than say log x. Okay, this implies that x has to be greater than y. Let's say this is y, this is x, right? So if log is this log is less than this log, and base is between 0 and 1, this will change, that is 3 minus 2x. This will become greater than 2x minus 1, like I have shown you here in the example. 8 was greater than 4, but if you take the base to be between 0 and 1, half, this changes, right? Log y becomes greater than log x. Okay, so this will have to happen. Since this base is between 0 and 1, this inequality will change. So this will imply that if we change the sides, 4 will come to the left hand side, 4 will be greater than 4x. So this implies that x will be less than 1. Okay, so we have this, and now we are given this. Okay, so this again, if we take intersection, taking intersection of 3 and 4, we are given, say this is 0, this is 1. Okay, x less than 1 implies that x belongs to minus infinity to 1, excluded 1, and minus infinity are excluded. Okay, so this entire region is the solution of 4. Okay, whereas 3 says that x lies in this region, point somewhere here, zero point 0.5 to somewhere here 1.25. Okay, this is the region where x belongs. Okay, so taking the intersection, we get x belongs to the common region that belongs to both 3 and 4 is this region between 0.5 to 1, right? As it covers the region for both the equations 3 and 4. So 0.5 to 1. Okay, so this is the final solution. It covers both equations 3 and 4. Okay, so therefore solution set is given by x belongs to 0.5 comma 1 or half comma 1. Okay, and this is the final answer. In the book also this was the correct option. In the book it was given as an MCQ, but I just solved it as a proper sum. Okay, so and another point is that value of 1.25 is this value. The square root of pi upon 2 is this, right? 1.57. So square root of pi upon 2 will be square root of 1.57, and this value is approximately your 1.25. Okay, so this is the value I have used here, and this was a bit complicated and computational sum. It took I required some time to solve it. I had to give a few tries, and finally I was able to solve this problem. Okay, so if you have any doubt in any step, you can just pause the video and just replay it. Okay, and if you think I have done any mistakes in any of the steps, you can highlight it in the comments. Okay, I will read it. Okay, so this is it. Okay, it is already a bit lengthy sum. Okay, so final answer is x lies in the range of half to 1. Okay, or 0.5 to 1 open interval. Okay, so this is the final answer. Thank you.